Hello, dear students. Now we are study about motion of class 9 physics. Actually, we are about to study motion and rest are relative. We will try to understand it conceptually, not theoretically, conceptually, that motion and rest are relative, not absolute. Not absolute, not pure. Not pure. Mean to say, absolute means you see me and said I am in rest. Anybody observe me and said I am in motion. It is not possible. Anybody not absolutely in rest or in motion. That mean to say, I will try my best to tell you what is relative motion and what is motion and rest are relative. What is the meaning of this statement? I will try my best to give you. But you will also ask to your teachers, your subject teachers in class. Actually, this is very important and very conceptual matter, that motion and rest are relative. Trying to understand to me very best. But you will also ask your teachers in your class, because he is just opposite to you. Okay, just in front to you. So your all the confusion will be solved. Now, actually, motion and rest are relative. To understand this statement, you have to understand this word, absolute. That means to say, this is an observer. Observer. And it is a point. Observers see this point. Only observers see this point only and say that's this point in rest. Either observers say this point and say that this is in motion. It is not possible, absolutely, exactly, truly, in reality, without seeing other any point, without seeing other any reference point, you cannot say that any object in motion or in rest. So it is impossible to say that any object is in absolute rest or in absolute motion. You tell me in motion, you tell me that I am in motion with respect to other point, with respect to reference point. When my position is changed with respect to that point, my position is changed. I am here and my next position is here. My next position is here. So my position is permanently changed to this point, to this position. So I am in motion. If this is reference point, this is a definite point, and my position from this point is not changed with time. My position is not changing with time from this reference point. Then I am in rest. In general sense, trying to understood very impressively, because it is a complex topic. In general sense, simply, generally, we say that any object in motion, when position of object is changing with time with respect to reference point, and any object set in rest when my position is not changed with respect to reference point with the time. So I am in rest. Okay. Now I want to say to you, there is some other examples of motions too. Some other examples of motions too, in which we cannot say directly by the position, by observing the position of object that is in motion or in rest. All time and every time, to observe the position of object, we cannot conclude that object in motion or in rest. For example, air blowing. Are you ever seen air? Ever seen air? Can you observe the location or position of the air? You cannot see the position of the air. You cannot observe the position of the air. So how can you say that air in motion? By observing the branches of the tree. When branches of the tree moves or vibrate, then you say that air is blowing. So air in motion. When gas is leaked from LPG cylinder, can you observe the position of the gas? No. You cannot see the position of the gas. You cannot observe the position of the gas. But gas is in motion when leaks from the gas cylinder. So how can you say that the gas is in motion? By smell. These are all indirect way by which we know that gas, air are in motion. Not always by locating the position, by know the position, by observing the position. All times we cannot know the object in motion or in rest by observing the position. Just like this, LPG gas cylinder leaked or air blowing. Air is also in motion. That gas that leaked from the cylinder are also in motion. But we observe these motion, how? From the branches of trees moving or a smell of the LPG gas. So these are all ways to know that gases are air in motion. And now I want to tell you something other else. Have you ever thought, ever you think, what is the reason of sunset? What is the reason of sunrise? What is the reason of changing of seasons? Have you think ever? Sunset, sunrise, weather changing, season changing. Why it is all possible? Never think about this. Actually, all these phenomenon happens due to the rotation of earth. Due to the rotation of earth on its axis. Earth rotates on its axis and revolves around the sun. Revolves around the sun. So there is two types of motion. First, earth rotate on its axis also and revolve around the sun. Earth, this is sun, this is earth. Earth revolving around the sun. Sun, earth. Earth revolving around the sun. And also earth rotate on its axis. Earth rotate on its axis. Earth rotate on its axis and revolve around the sun. These are two motions due to which weather changing, season changing. Then one question also. Sir, if earth is rotating, then why it is not seen? Why it is not seen that earth in motion? Why we cannot experience that earth in motion? We will understood this, but by other various examples. Okay, I will give you some examples due to which, from which you can understood that why we cannot see the earth is in motion. Okay. My dear student, listen me very carefully. Listen me very carefully. Very carefully. What I am saying. I am forgot to take mic. I am forgot to take mic. Listen very carefully what I am saying. Any object can be in the state of rest with respect to other object. That means to say reference point. Any object, just like me, any object can be in the rest with respect to other object. That means reference point, that is other object. And at the same time, object can be in motion with respect to other object. That means to reference point. My meaning is to say at the same time, at the same instant, any object may be in motion and also in rest. One object at the same time, simultaneously, may be in also rest and also in motion. Any object and one object same time, maybe in rest, maybe in motion. You are thinking, sir, how it is possible? It is possible. It is possible. When a person When a person sit in a boat, and boat is moving. Boat is moving. Boat is moving. This person is in the state of rest with respect to boat. This person is in the state of rest with respect to boat. The position of the person is not changing with respect to boat. And the position of person is changing with respect to water. When boat moving here, person moving this type, water moving here. It seems to this person. So person is in the motion with respect to water. When person in the boat and boat is moving in this direction. Boat is moving in this direction. The person is in the rest with respect to boat. And person at that same time is in the motion with respect to water. Understood? So one person at the same time is in the rest with respect to boat, and that person is in the motion with respect to water. So what is the result? What is the result of this statement? Result is that any object is in motion or in rest. Any object, that person is in the motion or in the rest. That person means object is in the motion or in the rest. It will be tell with the respect of other object. That is called reference point. Object in the rest with respect to boat. So boat is reference point and object is in the rest with respect to boat. And at the same time, the object, that means to say person, in the motion with respect to water. So water is the reference point. So the state of any object, I am object, my state will be described by the help of the reference point. Not only see to me, you can say that I am in motion or I am in rest. To describe my state that I am in rest or in motion, to describe my position that I am in rest, to describe my state that I am in rest or in motion, you will take help, the reference point, and according to reference point, I am in motion or I am in rest. Understood? At the same time, I am in rest with respect to boat, and at the same time, I am in motion with respect to water. So we can say now that my state, my rest or motion are relative. This is the meaning of this statement. That any object may be rest or motion. Maybe in rest or motion at the same time. Why? Because I am in rest or in motion, it will be described with the help of reference point. So we can say now that motion or rest are relative. These both state conditions are relative. Relative means that My state that I am in rest or in motion will be described with the help of any other reference point. Not absolutely, not see to me, you can say that I am in rest or in motion. Okay, completed now. Dear students, there can be various types of motion, different type of motion. Circular motion, linear motion, rotational motion, too many types of motions. And the motion of some objects are very complex. The motion of some objects are very complex. Why very complex? Because such type of motion in which more than one motion occurs simultaneously. Earth, rotation and revolution. This is rotation. This is rotation. Earth rotate on its axis and revolve around the sun. It is complex motion because two types of motion included in Earth: rotation and revolution. Earth rotating on its axis and revolve around the sun. Vibration, too many types of motion. In this chapter, mainly we will study about linear motion, straight line motion in this chapter. And also in this chapter, we will study that how can it will be possible that we represent the linear motion in equations, one line equation, to show the linear motion in equation, one line equation. Okay, I want to ask you that is board is in rest or in motion. I want to ask you, tell me, this board is rest or in motion? Sir, the position of this board with respect to earth surface, with respect to roof, with respect to floor is not changing. Last day this board is remaining here and will remain tomorrow here. So this is in rest. This board in the rest, because this board position according to this board position with respect to roof, with respect to floor is not changing. So this board is in the rest. Okay. And I also want to ask to you, beta, if we are sitting in a train, appears to us that I am in motion. Actually, my train is not running, my train is not moving. Why? Ever seen? Sometimes happens with you. You are seated in a train and train is not moving, but appears to you, feels to you, you experienced that you are moving. Yes, this will happen with everybody. Whenever I am seated in a train, and there is another train near to me on another track, not on my track. I am in a train and another train near to me. When that train moving, it's experience us that I am moving backward. It's experience us. Actually, train moving, another train, and I am experienced that I am moving backward. Actually, I am not moving. Okay. When we see outside the train to the platform and the trees, then we understood, I am not moving. I am in rest. Actually, I am one person. I am in motion with respect to that moving train. I am in rest with respect to platform. Understood? So, motion and rest are relative. It is defined with the help of the other points. I am in train and train is in rest. But we see another train that is moving, so we say that I am in motion and appearing that I am going backward. But when we see this side to the platform, then we say I am in rest. Okay, so my state that I am in motion are in rest. My state that I am in motion, I am in rest. My state that I am in motion, I am in rest is describing, is defined, is definite with the help of the other object. When we see the moving train, then I am looking in motion in the backward side. When I am seeing outside the train platform, that I am in rest. Okay, so I am in motion with respect to other train that is moving. I am in rest with respect to platform that is stopped. So motion and rest are relative, not absolute. Okay, that's now. So dear students, now we know explanation of motion. Explanation of motion. Trying to understood. Beta, to know the motion of any object, we must know the position of that object with respect to time. To know the motion, to describe the motion of any object, you have to know the position of that object with respect to time. We can determine the position of any object. We can determine the position of any object. We can determine the position of any object with respect to reference point. Also, we can determine the speed, displacement with the help of reference point. With the help of reference point. Actually, reference point, with the help of reference point, we know the position. Position means my distance from this point. If this is reference point, this distance is 10 meter. This is my position. Okay? And with the help of position, we know the displacement, we know the speed, we know the velocity. Okay? But to know the position, we have to know the reference point. To know the position, we have to know the reference point. And reference point is the origin point that I tells you. Reference point is a definite point by which we know the position changing of any object. Yes, that's I told you. My school is 2 kilometers away from my home. My school is 2 kilometers away from my home. So 2 kilometers is the position of my school. And my home, what is home? Home is the reference point. Okay? Now, something other is that's at the copy, this is north, this is south, this is west, and this is east. At the copy, it is north, it is south, it is east, it is west. North if come here, then minus north. South is go there, minus south. East is come here, minus east. West is go there, minus west. This is also the way to see. Any problem? This is all about. And now we will study about motion in a straight line. And chapter will forward in this direction. Motion in a straight line. Actually, you can say motion in a straight line is uniform motion. Motion in straight line is uniform motion, beta. Examples: an object falling towards the earth, an object falling towards the earth, object falling towards the earth. Straight line motion. Motion of train. Now we know other things. Dear students, to study the actual concept of motion and describe the motion, you have to know some other things. That is very important. Just like quantity, physical quantity, and other things. First, quantity. What is quantity? Very carefully understood this. When you can measure what you are speaking, when you can measure what you are speaking about and express it in numbers, you know something about it. That's meaning. When trying to listen me very carefully, when you can measure, what you are speaking, when you can measure what you are speaking and express it in numbers, you know something about it. But when you cannot measure what you are speaking and cannot express it in numbers, that's meaning your knowledge is unsatisfactory. I am speaking something and I cannot measure it. I cannot express it in numbers. So my knowledge is incomplete, not satisfactory knowledge. So anything that you can measure and express it in numbers, that is called quantities. Anything about which I am speaking, when I am measure it and express it in the numbers, that is quantity. So what is quantity? Anything about which I am speaking, when I measure it and express it in the numbers, that is called quantity. Okay. And now what is physical quantity? What is physical quantity? What is physical quantity? Listen me carefully. All quantities in term of which all quantities in term of which laws of physics can be expressed and which can be measured directly or indirectly are called physical quantities. What is the definition of physical quantities? Trying to understand carefully. Physical quantities. What is physical quantities? All quantities in terms of which in terms of which laws of physics can be expressed and which can be measured directly or indirectly are called physical quantity. Understood? All quantities in terms of which physical laws of physics can be measured and which can be measured directly or indirectly is called physical quantity. You know, in the word of Lord Kelvin, physics is the science of measurement. In the word of Sir Isaac Newton, God created everything with the numbers, weight and measures. Now we know there are two types of physical quantities. There is two types of physical quantities. Scalar quantities and vector quantities. Scalar quantities and vector quantities. What is scalar quantities and what is vector quantities? 1 minute. Before knowing a scalar and vector quantity, we know something other else. Actually, in 2013, 14, 11, 12, there will be a chapter measurement. That is very important chapter. First chapter of physics. That is reduced now. So there is some difficulties faced to the present time students. But we have to tell you. But you have to know something other else. To measure the physical quantities, you have to know two other things. In the process of measurement of physical quantities involves two things: unit and magnitude. In the process of measurement, to measure the physical quantities. Either you can say in the process of measurement of physical quantities, we have to know two things, unit and magnitude. To measure the physical quantities, how much light in this room? What is the length of, sir? What is the length of this pen? This is measurement. To measure the physical quantities, we have to know unit and magnitude. Either in the process of the measurement, we have to know two things. What? Unit and magnitude. So what is unit? The chosen standard. What is unit? What is unit? The chosen standard of the same kind of the physical quantity. As reference in order to measure a physical quantity is called unit. What is unit? Trying to know what I'm saying. What is unit, beta? What is unit? Any standard that is used to measure the physical quantity. Actually, just like this is length, this is length. So any standard, it is regarded as this is 1 meter. Let's consider this is 1 meter. So it is unit of length. That is unit. Take a block weighted. Take a block that is weighted. Okay, and you let that this is 1 kg. But that we use. We have taken that is 1 kg. 1 kg, 1 kg, 1 kg 10 times, that is 10 kg. So that is called unit. Okay. So what is unit? For the definition, the chosen standard of the same. The chosen standard, any standard that this is this 1 meter. This is 1 meter. This is 1 kg. Any standard that is used to measure, to comparison the same kind of other things. For general sense, the meaning of standard. Once again, try and understood. What is unit? This is eats. These are all eats. What is the quantity of this eat? What is the quantity of this eat? 1, 2, 3, 4, 5, 6. Sir, 6 eats. This is measurement. But what is mass of this eat? What is mass of this eat? Then we take a big stone. These 6 stones is equal to that big stone. So, sir, 1, 2, 3, 4, 5, 6. These 6 blocks is equal to this big block. One hand that 6 blocks, one hand that big blocks. These 6 blocks in one hand and these big blocks in one hand. Sir, these are all equal. So it is called unit. Okay. Any standard of same kind, okay, taken as in order to reference in order to measure the physical quantity is called unit. Any standard any standard of the same kind, any standard of the same kind, just like this, this is stone, so this is stone, this is stone, so this is stone. Any standard of the same kind taken as the reference in order to measure the physical quantity. Why it is taken? Why this standard taken? To measure this physical quantity. It is same type. This is stone, so this is stone. So this is called unit. Last time I will tell you what is unit. The chosen standard of the same kind, just like this. The chosen standard of the same kind, just like this. This is stone, this is stone. Any chosen standard of the same kind taken as reference in order to measure the physical quantity is called unit of that physical quantity. Okay? Any chosen standard of same kind, any chosen standard of same kind taken as reference in order to measure the physical quantity is called unit of that physical quantity. Understood? So what is the unit? Any chosen standard, this, that is chosen standard of same kind. This is stone, so this is stone. Taken as reference in order to measure the physical quantity is called unit of that physical quantity. So this is standard, this is taken to measure this physical quantity, so that is called unit. Okay? And now, what is magnitude? What is magnitude? What is magnitude? Trying to understood. 10 meter. Meter is unit. Meter is unit standard, and 10 is magnitude. How many times unit involved in measurement? How many times unit involved in measurement? Meter is involved 10 times. So this is magnitude. Actually, this is 1 meter, 1 meter, 1 meter, 1 meter. How many times meter involved? Meter involved 1, 2, 3, 4. 4 times. To measure in this line. To measurement in this line, to measure to this line, to measure to this line, meter involves how many times? 4 times. So this 4 is magnitude and meter is unit. Okay, so now over unit and magnitude. Let's meet tomorrow in next class with a scalar and vector quantities. Goodbye.